Hello, everyone. Good morning, and thanks for coming to this session and to this talk. And in this talk, I will introduce some tooling that I developed to ease the package development using Pluto as a tool to streamline some things. I'm actually didn't know until a few days ago that Andreas would be showing a talk using my package. I think is the first time there is someone that I didn't explicitly told about my package that I found out is using my package, which is quite nice. So just to recap, some information about me. My name is Alberto Mengali. I have a very unique name on every Julia kind of platform there is. My job is I'm a telecommunication systems engineer at the European Space Agency here in the Netherlands. But what I'm going to talk about in this talk has absolutely nothing to do with my work. I use it a lot in my work, and I developed it to help with my work. But it's just Pluto stuff. As it's written here, I'm a lover of Pluto. Like Andreas, I would like to do as much as possible in Pluto. I think it really is something that for me changed the way I was using MATLAB before, then I went to Julia, and then when I found Pluto and the reactivity and the ability to just change something, and while it's recompiling, all the cells are re-executed and just see your results, I think it's a very cool thing. And yeah, basically I also think Pluto is, to some extent, one of the reasons why I was able to push internally in my management to be able to do Julia development inside the space agency. And I did develop some packages that are registered in general. Most of them are Pluto-related stuff. I think the most probably used is Pluto Plotly, which is a Plotly wrapper to optimize for displaying in Pluto. There is this other Pluto Extras, which I think has cool features. I never really announced it. I never really published, so I think a lot of people don't even know it exists or features it has. I will show something in the notebook today coming from this. And then I have other packages and Pluto-related stuff. And you can find this presentation and the thing I'm going to show today on my GitHub on the link there. So if you want and you're interested, you can also check that out. So this is just a brief outline. I will give you an introduction about these two packages that I'm presenting here, which is PlutoDevMacros and another one which is called the PlutoVSCodeDebugger. I will go briefly on why I developed this and give at high level some implementation details. And then I will try to do a live demo of let's say, the highlights of the main features of this, mostly of PlutoDevMacros, but also a bit of the VS Code debugger. And then explain a bit of current, let's say, issues or weird things and what I'm planning to do next, mostly to address these problems. So this is a very one-slide brief what these two packages do. I think now, after Andreas' talk, it's a bit clearer to some extent what PlutoDevMacro does. There were some, of course, I'm a person that is only working on deadline. I'm a deadline-induced panic person. So I'm a hacker. I like to tinker with stuff. And when I knew I was gonna talk for this conference 1 month ago, so I was like, I have a lot of time. I have things that I want to implement. I will try to do this with this package. And in the last months, I completely rewrote the package twice. I did not manage to implement a lot of the things I wanted. I added new stuff, but that's, I think, how life works. So the PlutoDevMacros, as seen, is a way to import mainly local code inside the Pluto notebook. It tries to streamline this as much as possible without having to fiddling with the package manager and other things. The way I mostly use it is to some extent as a alternative to revise. To me, it's like revise with some additional benefits. It allows to automatically import in the notebook scope all of the names of the package you are loading locally. It allows, thanks to Pluto, to redefine structs, which is a very big pain point when in the early stage of development when you are iterating on your types. And then the very nice thing that is, again, thanks to Pluto, is that whenever you reload your code, everything that depends on it is re-executed. And while you're waiting for something, you save your file. And if you don't have very long-running stuff, it's nice to be able to just scroll down in the notebook and see what is the impact of the change you just made to your code. And then to help with this again, I also developed this other package because in my work sometimes we have to some extent complex function, and then sometimes we want to debug what is happening when the results are not what we expect. And I always lacked a good debugger. I think this is one of the probably only few things that I think MATLAB still has better than Julia at the moment. I think it's improved a lot. I like it now. But then in Pluto, it was a bit difficult to have some kind of interactive debugging thing outside of putting print or log statements. So at one point, I tried to see if I was able to hook a Pluto notebook inside a VS Code instance to be able to use the debugger. I managed to do it. It was actually much easier than I expected. So shout out to the people doing the VS Code stuff so that it was very easy to do this. The motivation a bit, I briefly already talked about this, but as I said, I fell in love with Pluto and I wanted to use it as much as possible for everything I did in Julia. And of course, at the beginning, there are a few things that are not very well suited in Pluto itself to use it for package development. I think I was one of the first people crazy enough to say, okay, I want to create packages with notebooks as files, and started developing PlutoDevMacros for this. This thing evolved a lot, and now I actually do not use like this in that regard anymore, because I think still that having notebooks as file is to some extent painful, mostly because now that with the package manager, the project and manifest are embedded in the file, it's a Git nightmare every time you update something. But nonetheless, this is still something that is supported by the package. Now I will show you a bit later how I use this more, but I think it's also cool to be able to do what Andreas was showing. It was how I started actually my Pluto journey. And I think it helps a lot with let's say the speed of development at the beginning. It allows you to focus more on changing what you want to change and immediately see what is the impact of what is happening. And then I also use this, again, I wanted to use this as much as possible for our package development, standard Julia package development. And so I always try to support as much as possible everything that the normal Julia package can support, which is like package extensions and other features. And the last point is regarding to the debugger, of course, as I said, I wanted to be able to use the notebook, but still be able, when needed, to hook into a kind of step in the debugger to see variables and other things. So the main feature that I wanted to have from the PlutoDevMacro package was, as I said, to work as a replacement for revise, mostly because of the struct redefinition and the reactivity, with some enhanced feature, of course. There are also some drawbacks with respect to revise, we will probably see, but I think I like a lot where this package is at this stage, and it's helping a lot our internal development. I also wanted to be able to load the package without explicitly having to put all of the dependencies in the notebook. This was the question from Stefan before. This we'll see how it works later, but it's very easy. It's probably not super straight, the best Julia way to do things, but I think it serves the purpose here, and it makes everything easier. But as it was shown, you have two separate environments: the notebook environment, which is that does not need to contain all of the dependencies of the package environment, which for me was a huge pain when I started this, because I really love the Pluto package manager. You just type using something and it installs it, does everything for you. But then when I was at the beginning starting to include other notebooks in my file, they were using different dependencies. I was getting error. I always have to go add all of the dependencies from every other notebook that is included in every other notebook that I'm using. So this was some effort to avoid this problem. Another thing which is a core feature, I think, for, again, development, is that you are able to open a notebook, include the package, and be in the namespace of the module you're developing. So you don't have to explicitly export all of your functions that you want to test to be able to have them like you would have, for example, in Revive. You don't or alternatively, you don't have to prepend the name of the module to the function in order to use it in Pluto. And I think this reduces the friction in the workflow. And as I said, one goal for me was to be able to support as much as possible what is support normally in Julia. So now the package works with package extension. If you have package extension on your local package and then in the notebook you add a dependency that is not on the package, it will trigger the extension of the package. If you have an init function, it's parsed and executed when you load the module in the notebook. Recently, I added support for all of this import XSY, both module names, so that everything is imported correctly in the notebook. Another thing that I recently added, which I think was cool, that is something that Revise does not support, is that you can have include with 2 arguments in your files and use a mapping expression within the local code. This is something I have some tests I added recently. It's probably break with the weird stuff. So if you want to try it, and if there is a problem, please let me know and I will try to fix it. And the last point is more related to what was the workflow show by Andreas, that if you use notebooks as part of your package source, so they are included in your package, and you use PlutoDevMacros inside the notebook will basically, in the notebook, the macro will load everything that is in the package up to the include of the notebook. So you will see it as like if that notebook was a normal file included in Julia. Nothing that is defined after that file is included is in the workspace. Nothing that is defined in the notebook itself is also brought into scope by PlutoDevMacros, because otherwise nothing would work. And so this was at the beginning to mimic as much as possible how the namespace is seen by a Julia file while loading things with include. So the basic usage is like this. Now this syntax is a bit new, but I think it's the thing I use the most now, which is this: you put some notebook anywhere in your package folder that you want to develop, and you did this from parent, which basically extracts the package environment and knows that you want to load this package. And then you just do import asterisk, and it brings into scope everything that is defined inside the package, so that you are able to access all the names and everything without putting the module name in front of it. This will also bring into scope, internally it uses names, but then since up before 1.11 in names, you cannot extract things that were imported by using statements. There is a lot of machinery going inside the package, so that everything is parsed and evaluated, so it tracks everything that is also brought into scope by using and re-put them into your scope in the notebook. This syntax below is before I had this thing that was also tracking using. Basically, for this problem of using, if you had a package that inside was like using benchmark tools, benchmark tool would not be imported in the notebook, and so that was there was this weird syntax to import a dependency of the package you're developing. And the reason why I have this very weird care things, that there is also a way to use normal words for identifying the package. If you see here, there is the package module, which is the root package of the local package. You have parent module, which is only applicable if your notebook is included in your file, and it's basically the module where the file is included. And then this dependency is only like this, but the reason I had this caret is that if you have the Pluto package manager and you have a normal word, you will see the bubble of the cloud saying download this. Even if this inside the macro of course will change everything and will adapt, so it points to different stuff. And instead, if you use this weird symbols, you don't get the bubble, so it was just a shorthand way to achieve what I wanted in the minimum amount of syntax and also avoid the bubble, which is not nicely looking when you see stuff. As you see, you can import things with a different name. You can import just specific names from any of the module. You can also import everything, not because if you just do import asterisk, it will import everything from the package if your notebook is not included in the package, or from the module where the notebook is included if the notebook is included in the package. You can also do this by specifying the module if you want to import everything from another submodule. You can also use relative imports if your notebook is included in the package. So as I said, all of this very complex thing is to try to support as much as possible standard Julia syntax so that it's as seamless as possible to use this for package development. So the same thing will work even when you load your package outside of the Pluto notebook. So some small implementation details. Basically, at high level, what this does, it basically, when you call it, you can call it either something I didn't say here, from parent automatically extracts the path from where the notebook is located, but you can also give it a specific path. If you have a notebook completely in another place and you want to load a package that is in another part of your system, then you can specify a path. You can also specify a path not just by a string, but a symbol that is defined in the notebook. But there are a few caveats with that approach, so I would go with the string path. And then, so the high level of what happens is you get the project based on the path you provide. To avoid the need of fiddling with the Pluto package manager, basically this adds that project to the load path at the end, so that you are able to load stuff without getting error from Julia. This works without making the package manager complaints, because all of the evaluation of the module happens during the macro compilation, so it does not trigger the Pluto package manager when you load a dependency. It creates a temporary module in the notebook space, and then it basically includes the module file inside the temporary module. It does not directly include, it uses like the expert from Julia interpreter, and it goes through all of it parts the file, it creates the expression and go and cycle through the expression, mostly because of what I said, that I want to track the using statements, and there are a few other caveats that I have to do while processing expression to populate the module. If it finds an init, it runs it, as I was saying. If it finds that there is an extension in the package and that all of the triggering packages are loaded, it will also load the extension code. It will also add a callback so that when other packages are loaded, for example, if you have an extension in your loaded package, but you still do not have the trigger package in the notebook, you can load this from the macro, and when the trigger package is loaded in the notebook, it will then load the extension. As I said, if you do this asterisk, it will import all the names, which I think is the most useful thing when developing. And then lastly, as the last output, it will basically just do some custom HTML and JavaScript so that you get a nice floating button to be able to reload the package easily, and also some stuff to prettify the output, because the temporary module, otherwise you see paths that are very weird. Some very small advanced detail use. So there is a way to avoid getting using statements from the import asterisk, because sometimes you have name clashes. I try as much as possible to limit the internals that I use and the assumption on the internals that I know about Pluto, because this can be problematic, but it needs still to use some internals to do what it does with let's say, as much ease of use as possible for the user. And there are some like situations which are set off by default, but they can be changed if needed. The two main parts, it's possible because, as I said, this package is basically a local module that is populated with the package code. Some things do not work when this is the case, like if you do package version with your package, it will not be a loaded package, so it does not know. If you put this flag to true, then it will register this as a root module. It will specify it to Julia where is its path. It does use internal, so it's a bit risky. I mean, it's not risky, it works, but let's say if you don't want to do it, that's not a default. But in case, for example, you scratch and you use the get scratch macro, which requires to know where is the package located to work properly, you might want to put this to true. By default, if the local package does not have a manifest, it will throw an error. But you can also override this so that if it doesn't find a manifest, it calls instantiate in the package environment. And then there is this other flag for verbose printing. But that's a small thing. The PlutoVSCode is very easy. It's just you connect it with the macro that I will show you, and then you can do run or enter like you do in VS Code to enter the debugger. And internally, it just basically calls it sends a call to the VS Code using the JSON RPC protocol. So now let's go for a demo. So for example, I have, this is my package folder. I have this package, which is just called simple antenna. I have this test notebook, which is the one I'm showing here, and I have the presentation notebook, which is the one I was using for the presentation. So this notebook will be used to show what happens if you include a notebook in your package. So for example, here, if I just do like this, there is nothing in this notebook, so the only thing that is brought into scope is the name of the package itself. Then, for example, I can go here and do a equals 3 and b equals 5. And you see this button, I can just press it and it reloads. And you see now A is into scope and B is not because it was after the notebook. I can see that A is actually 3. I can change this to 35. I reload. And this, sorry. Better? Then if I do put this inside the module, you will see that now this doesn't work anymore because now what I imported is not the root module, but the module where this file is included. And this works as expected for everything. I will not go into much detail here because we don't have too much time. But what I wanted to show that is nice is, so this is my custom table of content from PlutoDevMacros where you can hide stuff. So here what I wanted to show is a simple example of one thing which I actually use for work. It's a modeling of a linear phased array antenna. You can here do a struct definition. You can create some of your function to see where to position the elements of the antenna and to compute the pattern of the power in any given direction, which is controlled by, let's say, phased of the various feeds. Here, for example, I put a small plot, and you can see here the beauty of Pluto. Now when this thing finish precompiling, I will show here. I think the battery is not helping. So now here you see, for example, this plot that I've shown here. The nice thing of Pluto is that while you're developing, you can test what happens when you are increasing, for example, the number of elements, when you change where your antenna is pointing. And then if you go here, which is the notebook that is outside, I can also go here and do like this, and I will have brought into scope the module and the linear array. I can create it with something like this. Then I realize here, for example, I want to be able to specify that the spacing of my elements is not just 0.5, so I can go here and do spacing. Here I will just do, I will get some error here. So now I can get my spacing here. I can show that this can also be changed. But basically the gist is that this tries to simplify as much as possible. You can keep working on your notebook file. You can keep testing. You just do a change here. You reload your package by pressing this button. New things appear that you put in your code. And I think this helps a lot with all of the development.
Thank you, Alberto, for such an insightful talk. Are there... Are there any talks from the audience?
Thank you so much, Alberto. Same question. Like going to the Visual Studio Code, you have the project.toml. You're
Yeah.
managing this manually then, or is this also
The
somehow
project, yeah, the
included?
project in your local code,
Yeah.
it's like you would do a package. You have to decide which package you want to include and everything. But then once you have the project, you will basically just it will add that to the load path, so that everything that is there, it can be put into scope.
Yeah, thank you so much. Makes sense.
Any more questions?
Hi, thanks for the talk. It was very interesting. I'm just wondering what your feeling is about the fact that this takes package development to a very different place from what most package developers would do. And sorry, I'm over here. Yeah. So, do you feel that though that this is going to do you have the sense that you would develop a package in Pluto and you would always keep the development in Pluto?
No,
Or
so
that you would reach some stage where you say, okay, now I'm happy with it. Now I want to export it as a much more normal Julia package so that if somebody finds a bug, they can just dev the package and send me a patch and they don't have to learn a whole new workflow, in
so
other words.
as I said in the beginning, I don't use Pluto notebooks as package source anymore.
Okay.
What I do is I have a normal package, like so all of the things I showed you here, you could have just done in VS Code, changing code, redefining struct, and then reloading. The nice thing is that this way I'm able to redefine struct. I'm able to maybe put plots, do extension, and check this very easily in Pluto. But then now every package I do is normal Julia with no notebooks except just for testing, and then with CI and everything. So it's just really a tool for simplifying, let's say, assessing the new changes that you're putting in your package.
Excellent. Thanks.
So once again, thank you, Alberto. An applause for him.